Piecewise-defined functions. Piecewise-defined functions are functions that are defined using different equations for different parts of domain. Here we have piecewise function f of x is equal negative 2x plus 1 x squared plus 2, and these functions are defined in the area x greater equal negative 1 less than 0, and x squared plus 2 is defined in the area of x greater equal than 0 and less equal 2. We need to evaluate the following piecewise defined function for the given values of x and graph this function. Okay, so what can we say regarding a negative 2x plus 1? Let's write down here, negative 2x plus 1. First of all, the domain is between negative 1 and 0, right? Including negative 1, but excluding 0. So let's identify on the edge. If negative 1, if my x is negative 1, my f of x is equal negative 2 times negative 1 plus 1. It's going to be equal 3. And when x is equal 0, my f of x is going to be equal 1. Okay. So next, let's do the next one. Let me change here color so based on color you can figure out what I'm talking about. So now we are taking f of x is equal x squared plus 2. Let me write down f of x is equal, here also f of x is equal, nah, doesn't look good. Okay. Okay, much better. So for x squared plus 2, domain is x greater equal 0, less equal 2. That's our domain in this case. And whenever, so let's check the 0 and 2. Okay? So when x is equal 0, my f of x is going to be equal 2, right? When x is equal 2, my f of x is equal what? 2 squared plus 2, and it's equal 6. Since we have x squared plus 2, which tell us it's a quadratic function, so I want to take between 0 to and one more point, so I will see how curve will go. It's gonna open too much or a little bit, therefore I'm going to take x is equal 1, and f of x, it's going to be equal 1 squared plus 2 is equal 3. Okay, now let's draw the graph. Actually, this green color doesn't seem much. I'm going to get some much better color. This one will be, see, much better. That's right. Let me change also for graph also, it will be brighter so you can see better. Okay, let's graph now this price-wise function. So I need value of 6, so let me see. 1, 1, 2, 3, 4, 5, and this is gonna be 6. Okay, let me stretch this. Or maybe this one, even better. This one bring down. So I can clean this. No. And 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Okay, let me move one more down. Right here. So it's gonna be 1, 2, 3, 4, 5, 6. Okay. So first we are going to build negative 2x plus 1. Okay. So negative 2x plus 1. When x is equal negative 1, y is equal 3. So this is negative 1 and y is equal 1, 2, 3. Okay. This is 1 point, and when x is equal 0, y is equal 1. Here it is. Now, the thing is, negative 1 is included. 0 is not included. The point where that doesn't have the interval where equal sign is missing, we put empty circle. And it looks like this is 1, and this is 0, 1 point, and I'm going to build this piece of graph right here. And point of negative 1 and 3 is included because there is equal sign. Now let's build the x squared plus 2 in the area between 0 and 2. And in this case, both points are included, and 0 and 2. So let's see. When x is 0, y is equal 2. And I put here solid point because we have their equal sign, so 2 is included. Next, x is 1, y is equal 3. This is 1, then y is equal 3, this point. And lastly, x is 2, y is equal 6. This is 2, and y is equal 6. It's right here. Okay, so the graph is gonna go till here. So this graph now represent piecewise function. Okay, let's do another one example. Let's do with 3 pieces, function with 3 pieces. Okay. Evaluate the following piecewise defined function. So we have negative x plus 1, which is defined all the way less than negative 1. Next piece is 2, defined in the area x greater than negative 1 less equal 1. Negative x plus 3, And it's going to be x is equal 1. No, x greater than 1. Although there is also can be function that it's all equal. We take greater than 1. We don't want to get into advanced cases right now. Okay. This is another function. So before we graph this function, we need to make we can take a table of solution, or unless you know how to build a linear equation, the linear function, right? But let's figure out the domain. This is all our domains. X less equal 1, x is greater negative 1 less equal 1, and x is greater than 1. So I'm going to change colors. This one is going to be blue, and this one is going to be burgundy color. So let's build the graph. If you want, you can put the points. Okay, let me do that for you. So for x, negative x plus 1. F of x is equal negative x plus 1. So when x is equal negative 3, f of x will be equal 4, right? Because negative 3 going to be positive 3, okay. Next, x is equal negative what? We have negative 1. Okay, so f of x is equal 2. Because negative 1 is equal to. Okay, that's the first one. Let's do the second one. F of x is equal to. So domain is going to be x greater than negative 1. Let me write down domain. Domain is going to be limited area. That's why it's a piecewise. It's not the whole graph, but just piece. Piece from here, piece from here. Here we have 3 pieces of graph. So, and let's take any value. X is equal negative 1. F of x is equal to. X is equal, let's say, positive 1. F of x is equal to. Let me take point of 0. X is equal 0. So to find out if it's passing through 0 or not. F of x still equal 2. Right? Okay. And lastly, what we have, f of x equal negative x plus 3. Domain is x greater than 1. Since I wrote down domain there, let me put here also domain. I mentioned it, but I didn't put it. So here domain is x less equal 1, negative 1. Okay, so moving with the the function negative x plus 3. So when x is equal 1, f of x is equal 2, right? Negative 1 plus 2 plus 3. Okay, x is equal, let's take another value, 3. F of x is equal 0. Okay, now let's graph. Let's graph. Let's see what we're gonna get here. So numbers are small, the highest one number is 4, so let's see. 1, 2, 3, 4. Okay, let's go one less. Okay. And this one, I would like to stretch a little bit more. Okay. So let's start. Blue color. So x is negative 3. F of x is 4. 1, 2, 3. 1, 2, 3, 4. So this is going to be this point, right? And at the point of, let me see, negative 3, okay, it's not negative 3, it's not the edge of any domain. All right, so negative 3, and then we have x is negative 1. We always check the border of this domain. So here is negative 1. Let's see, f of x is 2. Negative 1 and positive 2. So less equal 1, every x that is less or equal 1, including negative 1, including negative 1, is part of the graph. So it's not going to be any empty circle there. Okay, next. Actually, I would rather use not arrow, but it's wrong to use arrow, because arrow meaning going to infinity, right? So that's why I need to take a piece at a line without arrows, which means it's only this piece. Okay. Next, blue color. We have 2 no matter what, right? From between negative 1 and positive 1. We have here negative 1. And positive 1 is going to be here, this piece. So let me provide line. All right, this is second one. And the third one is going to be x is, domain x is greater than 1. So it will start from 1 and greater than 1. Let me take the color. So when x is 1, f of x is 2. Okay, so it's starting from here. X is 3, 1, 2, 3. F of x is 0. Okay, and it's included or not? What do you think? It is not included. No, actually it's greater than 1, included. Okay. But when x is equal 1, let me see, it should be circle there. Let me check the function again. Yeah, it's greater than 1. Okay, so x1 cannot be, which means Here we have circle because we have equal sign, right? But in this case, so here is what is interesting. This positive 1, let me write down here, positive 1 for the function 2. Positive 1 is going under equal sign, see? Equal sign. So it's a full circle, right? But for this color, this burgundy color, we equal sign is missing. So where point 1 and 2, right, positive 1 and 2 is supposed to be a empty circle, right? Okay, but because we already have full circle, it's gonna overlap this empty circle because it's filled up already. So this graph, it's gonna only go down and there won't be any empty circle. Do we understand this? It's crucially important. Look here. See, we have the same point on both equations. And here is this one, right? In one case, it's empty circle, just like here. And in the other case, it is equal sign here, so which means it has to be full. If you have full and you have empty circle, if you put one on another, it's going to be full circle, right? Solid circle. Therefore, this solid circle overlapping the empty circle. And this is going to be our piecewise function. Okay? All right. So this is how you build the graph. Limited by domain, you build only half of the graph. And this way, function will consist of several other functions, or consist of graphs of other functions. Okay, short, but I think it's clear and it's good enough. You don't need more because it's pretty straightforward. Okay, if you have any questions, put in the comments and I'll gladly answer. Thank you.